Hi everyone, this is Miss Mancini, and we are going to be continuing with Chapter 6 today by factoring and solving polynomial equations. I know you worked a little bit on factoring in your last video. We're going to continue that today with some higher powers, and then eventually we're going to move into actually solving these. So if you remember from Chapter 5, factoring was just a tool we used to be able to solve for x, to find our x-intercepts or zeros, whatever you want to call them. Now, something that confused us in Chapter 5 that I want to highlight before we begin is how do I know when I factor and when I solve? You're going to use factoring if you're given an expression. So what is an expression? It's similar to an equation, except there's no equal sign. So it's just kind of like a mathematical statement. Like in number 1, that's an example of an expression. And when you solve, you should be working with an equation. So the difference between an equation and expression is that equation has its equal sign. So if it's set equal to something, you know you need to find what x equals. Now that we clarified that, we can go ahead and solve some of these. So start with number 1. We're given an expression, so you know you should be just factoring this one. Now, this is an x squared or a quadratic, so we should all know how to do this from our last chapter. You can guess and check, or you can split the middle. Since we're becoming pros at this, I'm just going to go ahead and guess and check. In order to do that, you know you're looking for two binomials that are multiplied together, and they need to multiply to be 12 and add to be 8. So when I guess and check, I like to be a little bit smarter and still create my t-chart. So I need numbers that multiply to 12 and then add to 8. So what are those numbers? And since we're pros at that, we can do this quickly. They should be 6 and 2. Okay, so remember when you guess and check, it's really like you're reverse foiling. So what are my first terms going to need to be to multiply to be x squared? Well, it should be x and x. Okay, then your outers and inners are going to need to add to 8, and your lasts are going to multiply to 12. So we already found those factors are 6 and 2. But remember, I need to guess and check. So I want everyone to check this on your own and make sure that's correct. If it's not correct, how can we edit it to make it correct? I hope you all paused the video and got what I got here. So the question is that the same as our original? And if you combine these inner terms, you see that they're going to add to 8x. So yes, it is the same. We don't have to change anything. We factored it correctly. So that one was a review, but let's look at one that's a little bit different, kind of similar, but it's definitely something new. So when we're working with higher powers, like x to the 4th, I want you to treat these just like you treat any other one you did in Chapter 5. So you should be asking yourself, can I pull out a GCF? If not, how can I factor this? So in this problem, there's no GCF we can pull out. They don't have any numbers that they have in common, and not all of them have x's, so we can't pull out a variable. So since we can't do that, we're going to kind of guess and check this like we did in the last problem. So your first terms need to be whatever is going to multiply to be x to the 4th. So if I'm multiplying two things to be x to the 4th, before, in the last problem, you saw that they were x and x to be x squared. In this problem, since it's a 4th, they're going to need to be x squared and x squared. Okay, now you need to see what's going to multiply to 12 and add to 8. So again, hopefully you're noticing this is similar to the last problem. So I picked this problem so we can use the same factors. It's going to be 6 and 2. Okay, so plus 6 and plus 2. Now if you're reverse foiling, your first terms should multiply to be your x to the 4th. Your outers and your inners should add to 8x squared. So your outers would be 2x squared, and your inners would be 6x squared. So those should add to 8x squared. And your last should multiply to 12, which everything checks out. We did it correctly. So when you're factoring this x to the 4th one, it's just like guessing and checking for your quadratics. Okay, so go through that reverse FOIL process. You can make your t-chart like I did in the first problem if it helps you figure out those factors. But remember, if you're guessing and checking, you need to check at the end. Moving on to number 3 then. We're going to go through the same process we did in number 2. So first thing you should always ask yourself is, can I simplify it up by pulling out a GCF? So looking at all these terms, what do they have in common? You should see that you can pull out a 4. Okay, but what about those variables? What do x to the 6th, x to the 4th, and x squared have in common? Or how many x's can I pull out of all those terms? Since the lowest power is a 2, we can only pull out 2 x's. So really your greatest common factor is 4x squared. Now, to figure out what the rest of your binomial is, you're asking 4x squared times what gives you 4x to the 6th? And that should be x to the 4th power, using those exponent rules we talked about earlier. 4x squared times what gives you negative 20x to the 4th? Should be minus 5x squared. And 4x squared times what gives you 24x squared? Should be just plus 6. And remember, since we're working with an equation, it's still set equal to 0. Once you've pulled out that GCF, you need to go ahead and factor what's left over. So again, I'm going to guess and check. We're going to ask ourselves, our 4x squared staying on the outside first, of course, what's going to multiply to x to the 4th? That should be x squared times x squared. Okay, then we're looking for what multiplies to positive 6 and adds to negative 5. So let's make our t-chart here, if we can't think of the factors off the top of our head. So if they need to multiply to be a positive but add to a negative, they're both going to have to be negative signs. So it could be negative 6 and negative 1, or it could be negative 2 and negative 3. Now the question is, which one adds to negative 5? And we should all see it's our second set there. So I'm going to fill in my minus 2 and my minus 3. And that still equals 0. So again, you need to make sure that if they multiply to be a positive but add to negative, they're both going to be negative. If you're guessing, you should go back and check. So if we FOIL this, you get x squared on the first terms, negative 3x squared, and negative 2x squared gives me my negative 5x squared, so we're good there. And my negative 2 times negative 3 gives me positive 6, so we're also good, and we know we've done this correctly. But since we all know now the difference between the equation and an expression, we should know that since this is set equal to 0, that we're going to have to solve for our x values. So I'm just going to erase my t-chart to make some room. Oops, if I could get my eraser to work. So remember our zero product property, that if any of these terms, so our 4x squared, my x squared minus 2, my x squared minus 3 equals 0, then the product will equal 0. Or you can say it as, I need one of these 3 terms to be 0, otherwise I can't get a product of 0. So in order to figure out what my x needs to be to make these terms 0, I'm going to set each part equal to 0 and solve for x. Okay, so one equation is 4x squared equals 0. One equation is x squared minus 2 equals to 0. And one is x squared minus 3 is equal to 0. These are all quadratics that you should know how to solve. So I'm going to pause the video. I want you to go ahead and solve them, and I'll come back with the solutions. I hope you all pause the video and are coming back with these answers. Sorry I write so big, I kind of ran out of room and rearranged some things. But your answers should be x is equal to 0, x is equal to plus or minus root 2, and x is equal to plus or minus root 3. Now you just have to get x alone, so remember, if we're solving for a variable, we work in reverse PEMDAS. So addition, subtraction first, then multiplication, division, then your exponents. Key to remember is not to forget your plus or minus when you're taking the square root. Obviously, you know, for 0, plus or minus 0 is just 0. If you have trouble with this, come back to class with questions, but this is old stuff, so I'm not going to spend a lot of time on it. On to number 4 then. So you have 25x to the 4th minus 36. Now in this case, is it an equation or an expression? Well, since there's no equal sign, we're not going to be solving, so we just need to simplify by factoring. For this one, I want to use a trick that we learned in our chapter 5, and that's the difference of 2 squares. So we used to use this with quadratics, but the same thing's going to apply to any problem where you have a difference of 2 perfect squares. So what's the perfect square? 25x to the 4th. What's a perfect square to equal 36? Now, in order to do the difference of 2 squares, I just want to remind you it has to be in the form a squared minus b squared, which we just talked about, and it is. And that's going to equal a minus b times a plus b. Now, I know we don't like to memorize formulas, So what I like to think about it as is I just need to find a and b. So if this is a squared and this is b squared, a and b are just the square root of both of those things. So what's the square root of 25x to the fourth and the square root of 36? So starting with a, the square root of 25 is 5. What's the square root of x to the fourth then? Well, it's really just what times itself is going to give you x to the fourth. That's going to be x squared. Now b, we need to take the square root of 36, which should be the easy part, is going to be just 6. So using our a and b, we're going to rewrite this. One is a sum, one is a difference. So our first answer is going to be 5x squared minus 6. And our second one will be 5x squared plus 6. And we can just leave it at that since we're not solving. Just to talk about the answer before I move on, the reason difference of two squares works is because your outer terms and your inner terms will cancel. So you will have no middle term, and then since you're multiplying the same numbers, they'll be perfect squares. You're multiplying the same thing by itself. So number 5 is another difference of two squares, except you need to solve. You should be able to do this on your own, so I want you to pause the video and try this using the shortcut. Again, if it's an equation and it's set equal to 0, you're going to need to solve at the end. So let's test everything you've done so far and go ahead and try this. I'll come back with the answer. Okay, so you should have used that difference of squares shortcut to figure out that your a value is 9x squared and your b value is 4. So you just make one difference and one sum, and the product is going to equal 0. Now, if we're solving, you need to set both parts equal to 0, which is what I did here in the blue and red. And your final answers are x equals plus or minus the square root of 4 over 9, and x equals plus or minus the square root of negative 4 over 9. If you got that, great job, but I want to remind you that you need to simplify these radicals. So x equals plus or minus the square root of 4 over 9 is really plus or minus 2/3. Your negative version is the same, except you have to include an I with a negative radical. For all those people that aren't listening right now, you're probably not going to write that on your paper, and I'm going to call you out in class tomorrow. But if you are being a good student and watching the video how you should be and listening to everything I have to say, please write those simplified answers I read down on your paper, so only the ones who weren't listening are the ones to suffer. And of course, then you have your full simplified answer. Last problem. So we're going to go through and factor this before we can actually solve it. So the first thing you should be asking yourself every single problem you do is, what do 2x to the 5th and negative 18x have in common that I could factor out? In other words, do I have a GCF? If so, what is it? In this case, you can certainly pull out a 2 since 18 and 2 are divisible by 2. You can also pull out 1x. Continue to rewrite that problem then by asking yourself what's left over. 2x times what gives you 2x to the 5th? Should have 4 more x's. 2x times what gives you negative 18x? That should be minus 9. And that's equal to 0. Now if you think about this, this is again going to be a difference of two perfect squares. We should be pros at this by now, so I'm going to pause the video, and I want you just to factor the rest of this problem using the shortcut of the difference of two squares, or you can split the middle if you so choose. So pause it, and I'll come back with the factorization. Okay, if you use my shortcut, you should have quickly gotten 2x times x squared minus 3 times x squared plus 3 equals 0. Now the thing I want you to remember when you're doing this is that this 2x doesn't just go away. It is another factor of our original problem. So it needs to stay there throughout the problem so we can use it in the end when we're solving for our x's. Okay. Now that we factored this, you should be able to solve for your x's by setting each part equal to 0. So 2x equals 0, x squared minus 3 equals 0, and x squared plus 3 equals 0. Since we're running out of time, I want you all to go ahead and solve for your x values on your own at home. We'll go over these in class, and if you're in Miss Mancini's class, we'll also talk about your summary and your question that you need to write. I hope you all were active with this video and learned a lot about factoring and solving. Again, if you were active with this video, you should have been writing down questions and pausing the video as I told you to or as you needed to. So come tomorrow ready to participate in class and make sure you ask your teacher whatever you didn't understand. Hope you had fun and have a good rest of your night.